Good morning, everybody, and once again, welcome back to the part 3 of From Zero to Hero Building a Dynamic Data Platform like a Pro on AWS. In this part, this is the most crucial part of the video because in this part, we are going to be building the most important component, that is the job metadata, dynamic scheduler, everything, right? So all of that is coming in this video. So probably this video will be, I'll let you know that this video would be a little bit difficult, but again, my goal will be to make things easy for you. There is almost close to 600 lines of code now, but don't get afraid. I'll make sure that I explain you everything in steps, okay? So what is the goal of the video? Well, we were just a little background for people who are watching directly third part. The goal was we want to design a framework that essentially allows us to ingest data from raw into Silverzone, into Hoodie, transactional data lake in an automated fashion. We want to automate the infrastructure component. We need job scheduling. We need manual files, everything. So we want to build this data platform. So in this part, let me expand this one. In the last part, part 2, I showed you how to automate this particular block, right? So we basically wrote the infrastructure and we were creating infrastructure component on the fly. Now this part is going to be the most important fun part. We're going to be designing the job metadata. We're going to be designing the scheduler as a system, which means dynamically scheduling, right? So we're going to design all of that in this particular part. So now that you know what we're going to design, so let's get started with the video, all right? So again, I will be going back to my IntelliJ IDE. All right, before I show you all the code, which is, 500-600 lines, let's talk about what we need, right? So now we know how to automate the infrastructure component. Last part 2, we did that, right? So now what is the need, right? Now we need to store these metadata in some sort of a database, right? You can opt in for any database. I'm going to be choosing Amazon DynamoDB. It's a NoSQL, suits my application, right? So I'm going to be choosing DynamoDB. Now, before we go into all the nitty-gritty details, let's understand what are the parameters that we need for a job. The first requirement I have is I need to know who is the person who created a job. So a name of a person. So created by, created at, what time did he create the job? I want to know that. Is the job active or not? So a flag would be great to have, like, whether the job is active or is inactive, right? So I want to know that. After that, I probably want to know if the user has decided to schedule the job. In that case, when would the user like to schedule the job, right? What is the frequency of the job, right? So I would want to know these details. After that, I would like to know the input path, the user where he wants to ingest the data, and the output part where he wants to dump the curated transactional data, like, right, the Hoodie part, right? So we need to know that. Then I also need to know if the user would like to perform some transformation on the data, because there will be times when the user might want to transform the data. So the framework needs to support all of these, right? So I would need an ability to pass in a SQL query, right, into that. So that makes sense. And then probably some of the settings for the Hoodie, we should be also incorporating that into the job metadata. Other than that, I cannot think of anything else. So now let's begin the design part. All right. So there's a lot we need to cover for sure, right? So, but let's cover the first part, that is the job metadata. So I told you, right now, I just said, right, we need a way to know whether the job is active or not. So a flag would be great to have. Who created the job? So I want to know who's the person, right? So that way it's easier to locate, and contact that person, right? So that would be great. A cron job. So if a person decides to put this job on a cron, how often he or she wants to run this, right? A batch job. This one right here, the job name would be the glue job name. So again, remember in the architecture that this particular job is gonna be fired through a Lambda function, which is gonna pull all the metadata, and then it's gonna pull that queue, the infrastructure that was created on the fly, right? So that's the glue job name or the template name, right? The Lambda function, this would be the Lambda function, which will be fired through an event bridge, which will pull the metadata from DynamoDB and pass it on to the glue job, right? So that's the Lambda function over here. Again, I'm just providing that. But again, this will be an env variable, right? But for now, since I'm teaching you, right, I'm teaching you how to think, like how to develop this platform, right? So I'm providing everything as a JSON for now. So I would need that Lambda function for sure. The table name. So what is the table name that I'm trying to ingest? So again, from the front end application, there will be a drop down where customer will say, hey, this is customer, this is order table, etc., etc. So that's that. Here, this is the S3 config. So basically, this will tell me select the bucket, right, and which particular folder you are interested to ingest data. In this case, it's raw customer. I'm just showing you an example. The user also gives a table name and the account ID, etc. Now, once that is done, remember, as you know that, right, in the framework, the glue job, let me switch my screen. My camera is a little lagging. I'm not sure. Okay, it looks fine now. But yeah, all right. So this glue job, remember, it will pull all the metadata, right? So this is the glue payload. So all the job metadata that the job might need would be stored in this entity called glue payload. For example, hey, do I want to use Apache Hoodie Cleaner? Do I want to use HiveSync? Do I, if yes, which glue, if I'm using HiveSync, right? The glue database name, glue table name, record key, pre-com key, table type is copy on write, if you want to partition the data or not, the target where you want to store the data, any SQL transformation, which means if I want to transform the data, right, I could pass in an SQL query and so basically all of that, right? So this is the master payload, right? So this payloads tell me, okay, who did the job, who created the job, what time it is created, is it active or not? Then it tells me which S3 path the data has to be ingested from, where it has to be dumped, and all the particular hoodie setting. So this is sort of the JSON which defines the entire framework. So again, now the only thing you got it, right? So now later on in the next part, not this part, this particular JSON payload will be converted into a microservice, we'll build a Swagger UI. But this is the backbone, is all I'm trying to say. So hopefully made sense, right? Everybody so far with me, right? Okay. All right. So collapsing back. So the main function, right? Then I have a class called glue ingestion framework. So I made a facade class. So I have a lot of functions and wrapper class, right? So I made a main class, which is called glue ingestion framework, where I'll pass all these parameters and which will call all these subclasses, right? Hopefully that makes sense. So if I scroll down a little bit, my computer has started lagging right now, not sure why, but again, I now call create glue ingestion job with cron, so I pass in all the parameters. Now let's see what magic is happening inside this function, right? Here is a constructor, here is a constructor, right? And then here is the method. So the first thing that I check is I check if the user has passed in the S3 conf, which means if you haven't provided the S3 input path, it's probably gonna error out. So I need some checks before doing all those other parts. So the checks are, hey, check if the user has passed in all the values in the S3 config, the entity that we defined. Then there are some other checks. For example, that's one of the checks that I did. Again, you can add other checks if I have missed any, right? Now come here. Now here, this one is basically the dynamic rule name, right? So I want to automatically create a rule, right? So basically, this is going to create a rule. If you haven't passed the flag active, whether the job is active or not, by default, it will be disabled, right? So I'm taking care of that. And here is the logic, right? If active, true, or true, set the state to enabled, right? So basically, as you can see, I'm taking care of all those cases here. Then here is the class input triggers. This is the class which will create that dynamic cron, right? And then once that is done, what I do is I create all the infrastructure component, the SQS queue, the dead letter queue, the S3 events. So this particular component over here is automatically created on the fly. After that, I check if it returned a valid response. If it did not return a valid response, I stop the code right there. So I say fail to create resources. As you can see, I have a check over here. Now, at the end, I only commit to the job metadata. So I only commit to the job metadata if and only if all the other components have passed, right? So if the event bridge rule was created successfully and the infrastructure was created successfully, as you can see in this if statement, then and only then come inside, and then this is a job metadata DynamoDB class. So as you can see, if I click here, again, pretty simple, right? All the parameters I defined here. So all I do here is, if I scroll down, I call .save method and I return true. So in a nutshell, this class, I'll show you this in action in a second. This class will basically do all the heavy lifting for us. It will create automatically an event bridge rule, which will fire up that Lambda function. In that Lambda function, we will write that logic, which will read the data from the DynamoDB and pass it on to the glue job. Once that is done, this particular template also creates the infrastructure, the SQS, the dead letter, the S3 events. It configures everything. All of that is being done in this template. It's amazing, as I said. All right, so you want to see this in action, right? So again, you can definitely read the code. I have tried my best to put comments as I can. So infrastructure on the fly. This is all the code related to the infrastructure. This is all the code related to DynamoDB. And this is the code related to the event bridge and scheduling, right? So hopefully I tried my best to comment out as much as I can, right? Now, hey, let's see a demo, right? So, all right, now let's rock and roll. Let's try the entire solution out. So the first thing that we need to do is we need to create a DynamoDB table. So I'm gonna be doing that in the Python function. So call the Python function, create DynamoDB table, and right click and simply run the Python file. Again, ran successfully. If I go back to my DynamoDB, as you can see, I do have a table now called dev.hoodie ingestion framework. As you can see, this is the table that got created, right? Now that you have a DynamoDB table, we need an S3 bucket so that I can show you everything in action, right? So what I'm gonna do over here is I will try my best to create a bucket for you. Again, you can create the bucket with whatever name that you like. So I'm gonna probably copy this, create bucket, put the name over here, and click on create bucket. So now I have an S3 bucket and a DynamoDB table. Now what we're gonna do is we are gonna run our Python template, which will do all the stuff for us, right? So let me show you that. Back to my screen. All right, just zooming out a little bit, so making sure that you guys see. So remember, the code will first go ahead and again create an event bridge rule with that particular payload. Then the code is gonna create an SQS queue, a dead letter queue. It's gonna configure the dead letter queue with the policy. After doing that, the code will integrate, make sure all the events from this particular folder, raw_customer, will be pushed to that SQS queue. And then after at the end, the code is gonna commit all the job metadata to DynamoDB. Rock and roll. Let's see. Before I run this, I want to show you that I do not have any SQS queue over here. So if I come to the SQS again, as you can see, I don't have any SQS queue. I do not have any rule with customers, right? So now let's see this in action. This is the bucket. This is the path where I want to configure the events, right? And I'm gonna run this template now. Let's see how things go. So coming down, I will comment out this one and run the main function. I'm gonna run this, okay? All right, 3, 2, 1, go. So first, it will load all the imports. Here you can see, is able to configure the SQS, the dead letter queue, configured the event bridge rule, and then it committed the job metadata. Shall we see this now? All right, so I'm gonna come to the event bridge, the first thing. So as you can see over here, glue job fire customer, automatically it created a rule. Automatically these are when the next job will be fired. If I go to the target, this will fire up that Lambda function that we provided in the payload. And if you click on the input, here you can see, it's a little hard to see, but here you can see the job payload. Here you can see the job name and the table name. This is the primary key, this is the sort key. We can query DynamoDB, grab all the parameters and pass it to the glue job. So makes sense. So the dynamic scheduling is working fine, right? So that worked fine. Now going back to the SQS queue, if I refresh here, I should be seeing my 2 SQS queue. That is the customer ingestion queue and the dead letter queue. Works absolutely fantastic, right? If I go ahead into this bucket, go to properties, automatically an S3 event should be configured here. So if I go to properties, if I scroll down, as you can see, automatically that notification has been configured, which will listen into this particular prefix and it will pass all the information to that SQS queue. So you saw that, right? It's working flawlessly. It basically on the fly made an SQS, a dead letter, configured the queue policies, After that is set up an S3 event. After that, it also configured the event bridge rule. It set up the event bridge rule with a payload, and it's going to fire the Lambda function. When the cron happens, that payload will be passed to a Lambda function. The Lambda function will query DynamoDB with the primary and sort key, grab the job metadata, pass it to the glue job, and that's it. You see how everything is working flawlessly. So this is the Python code that I show you. Now, only thing that is missing is a API, right? We just got to wrap this entire code around a Swagger UI, and that's it. That's it, right? So again, the goal is to teach you guys all these important concepts that's probably is not available on Udemy or any YouTube videos, right? These are actual real world projects that you're gonna, you can try and learn and develop your skills in AWS, right? All right, so with that being said, if you want to try this one, this is part 3. The next part, again, I'm going to write probably either the Lambda function or the API. So first, go ahead and create the S3 bucket, create the DynamoDB table as I showed you in the video, and then run the main function. This should create the event bridge rule, the SQS queue, the dead letter queue, and the S3 event. See everything is working or not. So thank you so much for watching. I hope you guys are enjoying these videos. And if you do enjoy these videos, do let me know in the comment section. And I will see you in the part 4 where in part 4, I might be programming the Lambda function, or I might be probably doing the Flask API thing. But anyways, I'll be seeing you. I'll be very, very happy to see you in the next part, that is part 4.